Hello surveyors, how are you? Hope you all are doing fine. So today I am making this video on the request of one of our surveyors. He wants to know that how in RiScan Pro we can generate contours or sections, in other words, using a point cloud data. So today I'm going to show you how using a point cloud data we can generate contours. I have imported one of the point cloud data and named it as AOI in project manager's point clouds folder, and I'll drag and drop this data. Let me open it in a single color, pink, and I will click OK. So this is my point cloud, and using this point cloud data I have to create the contour lines. We cannot directly create contour lines in the point cloud. We first have to convert this point cloud data into 3D surface using modeling and making a 3D terrain model. So for that, what I have to do is I have to create the polydata of this point cloud. So the first step is to create the polydata using the point cloud. So how do I do that? Firstly, I will press Ctrl plus A and select the entire data, and I will convert this entire data into polydata by going in the option here, copy selection into new polydata, and clicking on the copy selection into new polydata option here. And the new polydata will be created in the project manager's polydata subfolder. So my polydata has been created. Its name is polydata 001. Okay, I will close the working window. And if you want to rename this polydata, then you can rename it. Let me rename it AOI. Okay, and press enter. Now I will open this polydata in the working window. Okay, so after opening the polydata in the working window, what I have to do is I have to make solid model or the terrain model. So for that, what we have to do is first again Ctrl plus A to select the entire polydata, and then go to triangulate selected data and click on it. Small pop-up window will open, and you have to input some parameter here. So in the first option, maximum triangle edge length, you have to give the edge length of the triangle using which this polydata will be triangulated. So it totally depends on the density of the data. See, in the majority of our polydata, as you can see here, the points are 10 meter, 15 meter, 20 meters apart. So I will start with smaller values. Let me start with 30, and the crop triangles outside polylines option should be unticked, and click on triangulate. So I have created a 3D surface. However, there is one area where the triangulation process has not run. So I have to make the surface in that particular hole also. So how we do that is firstly deselect the data by going here and clicking on it. The data will be deselected, and I will activate the selection mode and select that particular area only. And after finishing the selection, I will right click to finalize my selection, and the data will be selected. Now since 30 meter edge length has not covered this polydata and has not converted this into a solid surface, so I have to increase this edge length so that this hole could be filled. So use a 50 meter value and again click on triangulate. Okay, so the hole has been filled. Now my triangulation process is finished. I will close this window and deactivate the selection mode and deselect the selected data here by clicking over this option. Now the surface has been created. So the second step has finished. Now the final step is to create the contour lines. So to create the contour lines, firstly make a reference plane with respect to this surface here. So to make a reference plane, go to create new plane object and click on this drop down menu and choose the coplanar with XY plane option, and you will see a plane will be created. Before moving forward, we have to make sure that this plane should not cut the surface. So I have to shift this plane downward. So how we do that? We go in the object inspector and choose the plane, and corresponding the properties of this plane, there is a option called origin. So in the origin option, I will go to Z value and decrease the Z value because I am already at this level. So to move the plane in downward direction, I have to further decrease the Z value. It's been already 0. So decreasing the Z value means going even below 0 value. So I will put an arbitrary value. Let me put -100 and press enter. Plane will be shifted. So it doesn't matter how far we put our plane with respect to our polydata. The important thing is just make sure that it doesn't cross the surface. Okay. Now you don't have to do anything. Just go to this create new section objects here and click it. A pop-up window will open and it will ask the parameters. So firstly we have to give the name of the section. So let me give it as contours underscore AOI. I have to move along Z axis. So in the mode option I will choose along Z axis value, and step width is how much meter apart you want your contour lines to be. So let me choose it to be like 1 meter. You can choose any value and don't change anything else, and click on create section here. It will ask no triangulated polydata object selected. Do you want to use all data? So since we have to make contour lines for the entire data, I will click on yes. See, the process is running. We can see the progress of the process here. It will take some time, so be patient. Okay, the process has been finished, and in the object inspector also you can see that contours AOI 001, 002 up to AOI 135 contours have been generated. To see the contour lines more clearly, I will select the entire contour lines. Now I have selected all contour lines, and I will make few changes in the property here. I will increase the line width, let us say 3, node size to be let us say 5, and the line color I'll change it to be yellow to be more clear, and the node color also, if you want to see, I'll make white to differentiate. If I want to see the node also, then tick this value. Okay, but it will become this type, so it's better not to see nodes. Alright, so these are contours. If I want to see only contour lines here, I will hide the point cloud by going in the object inspector and clicking on this small triangulated icon here, and the 3D surface will be invisible, and this reference plane is also creating some problem, so I will hide that too. I'll go to the reference plane in the object inspector and I will hide it. So now you can see that we have created the contours. So these contours are 1 meter apart. Okay, so now the most important thing is to export these contour lines. I'll close this working window first, and in the sections sub option you can see there are sections which I have created. They are like contour AOI 001 to contours AOI 135. So I'll select these contour lines and right click here and click on export. A pop-up window will open, and it will ask to browse my data anywhere I want. So I'll save it in, let's say, desktop only, and I'll have to give the file name. I'll give the file name sections, and save as types. You can see there are many options here. One of the option is AutoCAD.dxf. So I am exporting this data in AutoCAD.dxf only, and if I want to save the contour lines in each separate layers, then I have to tick mark this option, or if I will untick this option, then the entire data will be saved in one single layer. So that's up to us. It's always better to use separate layers, so tick it and click on save. Another pop-up window will open and it will ask which coordinate system you want to use. So always click on global coordinate system and click OK. and the file will be exported. So this is how you will create contours in RiScan Pro and export that contour lines in .dxf format, and that file could be opened in CAD or some other software. So I hope you enjoyed the video. Till next time, thank you.